This is section 7.3, page 1 on proportional reasoning. First definition we have there is if A and B are real numbers, B not 0, then the ratio of A to B is the quotient A over B. So ratio is a fancy word for fraction. Okay, so they're just asking you to write a fraction. Ratios compare one quantity to another, like in miles over hours. So we have miles per hour. We talk about that when we're driving. Number of answers answered correctly over total number answered. So that's, how we work a test question. The price per pound, number of hits over number of times at bat. So that would be batting average. Okay, so let's try problem number 2. It says there are 32 red, 24 blue, 16 green candies in a bag. Express each of the following ratios in simplest form. So that means when you're done, you've got to make sure that there's nothing in common there. Okay, so red candies, they're asking you to write this fraction. They're saying write red candies over green candies. So it's always in the order that you see it. Okay, well, how many red candies are there? There are 32. How many green candies are there? There are 16. So 32 and 16 have something in common, 16. So if we divide both by 16, we get 32 divided by 16 is 2, and 16 divided by 16 is 1. Now here's the rare case that we want to leave the fraction like this. We don't want to write 2. Because they've asked us for a ratio, we want to make sure we have a fraction. Okay, so 2 over 1. Okay, now we're going to try green candies to blue candies. So green candies in the numerator, blue candies in the denominator. So green, 16, and blue, 24. Okay, so in this case, what's in common? Well, I see that there's an 8 in common, so divide by 8, divide by 8. So 16 divided by 8 is 2, 24 divided by 8 is 3. So before you circle it, take a look. Is there anything else in common? Nope, that's simplified form. So we're done there. Okay, go ahead and pause, do your classwork, and then come on back. All right, definition for proportion says that two ratios, so remember that's just two fractions, are equal. Okay, so A over B equals C over D. Of course, B and D cannot be 0. Okay, denominators can't be 0. So A over B equals C and D over D if and only if you can what we call cross multiply. These are the same. Okay, so you may wonder why that is. Let's go ahead and take a look real quick at why that is. So what I'm going to say is that what we're trying to do here is get rid of the denominators, right? This has no denominator. So to do that, to get rid of this denominator, we would have to multiply both sides by B. Okay, whatever you do to one side, you got to do to the other. To get rid of this denominator, we'd have to multiply both sides by D. Okay, so you're multiplying both sides by BD. Okay, well, what happens? Well, these B's cancel, and these D's cancel. And what do we end up with? We'll end up with here A times D, and over here, B times C. So that's how they get that, all right? So let's see if these proportions are equal. So what we're going to do is we're going to cross multiply and see if they're the same. So we would say 20 times 48, and we're asking ourselves, does that equal 35 times 28? Okay, so here you might want a calculator. So let's see, we have 20 times 48 equals 960. And does that equal 35 times 28? 980. Okay, so, of course we could have done that multiplication, but we were trying to be quick with the videos. So are those equal? No. Okay, so no. This is not a proportion. Because when we cross multiply, they're not equal. Okay, let's try the next one. So here we're going to try to multiply like this, and we're going to get 20 times 49 equals 35 times 28. Okay, well here when we multiply, we're going to 20 times 49 is going to be 980. You can do that on your calculator. So this is our question mark. We already did 35 times 28. That was 980. Okay, so what do we get there? Well, this time they are equal. It's true. So yes, this is a proportion. Okay, so that's it for page 1.